Okay, I need to go over this idea I have because I made a incorrect statement in one of my videos where I was pointing out that these wavelengths right here were orbital distances, and that was not correct. I did not mean to state that. What I meant was that you can get the orbital distance by using wavelength as a circumference, and by using angular velocity equations you can mathematically prove that wavelength does double as a circumference, and by finding the radius of the circumference or wavelength, then you get the orbital distance. The radius becomes the orbital distance if we turn wavelength into a circumference, and I can mathematically show this by, we can use these equations right here. The speed of light divided by wavelength equals frequency. Speed of light divided by frequency equals wavelength. And then to get the angular velocity using frequency, you take frequency, times it by pi, times it by 2, and then you get its angular velocity. Okay, so we'll do that first, because that's not using wavelength as a circumference. That's just using speed of light, frequency, and pi to get angular velocity. So we'll use 486.1 nanometers. So we go 1, 2, 3, 4, 5, 6, 7, 8, 7, 1. So we're going all the way to the 10th decimal place, which is the 1/10. So this is 1/10 of a nanometer. So this is how you write out the 486.1 nanometers in mathematical longhand. So this is how it's written when you want it, and this would be meters, and this is nanometers right here, the 6. So we take this. So we'll take the, let's see, we take the speed of light divided by wavelength equals frequency. So 299792458 divided by wavelength. Okay, so this is its frequency right here of 486.1 nanometers. This is its frequency, how many times it orbits per second at the speed of light. So now we take frequency, times it by pi, times it by 2. So times this by pi, times it by 2, and this is what we get for angular velocity by using speed of light, wavelength to get frequency, and then using frequency and pi we get this as the angular velocity. Now we're going to double wavelength as the circumference now and see if we can get the identical angular velocity by finding its radius, because we can use the speed of light divided by radius equals angular velocity. So we're going to find wavelength. We're going to do wavelength divided by this number right here is 1 divided by pi. So we're going to use the 1 divided by pi. We're going to times that by wavelength, and that's going to equal the diameter. That's how you double wavelength as a circumference. You times it by 1 divided by pi. So we're going to take the wavelength, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, darn it. Sometimes it doesn't read the number. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's wavelength. We're going to times it. We're going to copy this number right here, which is 1 divided by pi. That's what this number is. So we're going to times it by that number, times wavelength by the number which is 1 divided by pi. So wavelength times I wish there was another way to say that. 1 divided by pi, which is that number, equals, so this would be its diameter, so we divide that by 2, and we get this as its radius. So this radius number right here is the orbital distance of an electron at this wavelength right here. So this is a wavelength. This is not, I stated in the other video that this was an orbital distance, and that was not correct. You can get the orbital distance by finding the radius by doubling the wavelength as a circumference. So now, to get the angular velocity, we take the speed of light divided by radius, and we're going to get the angular velocity. So we're going to copy this radius number, copy it, okay, clear it out, so 299799245 the speed of light divided by radius, the radius that we just found by using wavelength as the circumference, and what number do we get? The angular velocity number we get by doubling wavelength as the circumference is identical to the angular velocity number we get by just using the speed of light, wavelength, and frequency, and pi. So if they're identical, then that means that wavelength does double as a circumference, and this is mathematical proof that that is correct. See, if we take this number right here and we divide this number by that number, or vice versa, if we just divide one of these numbers by the other number that we found, it's 1. So these two numbers are identical, exactly identical, by using pi, 1 divided by pi, and doubling wavelength as the circumference, and getting the identical number for angular velocity means that wavelength does double as a circumference. So when you see the wavelength chart where between one peak of the trough and then the next peak of the trough, that's like one full circle that the electron does when it orbits. So that whole circle that it does is a circumference circle, and by using these formulas over here, we mathematically have proven that wavelength doubles as a circumference because we get the identical angular velocity by using the speed of light divided by wavelength equals frequency, and then frequency times pi times 2, and we get an identical angular velocity result. So that's what I wanted to show and mathematically prove in my last video, but I did not follow my own instructions. So the radius, when you double wavelength as a circumference and you use that with this equation right here, and you find its radius, then the radius is the orbital distance. Okay? That's what this number is right here. This is the radius that we found. So this would be the orbital distance of an electron at this wavelength. So that's how you find orbital distance, by using wavelength as a circumference and using these equations that I have written down right here. Okay? So that's what I wanted to show. Hopefully this has cleared everything up, because I was looking over my older videos and I did not do the demonstration and mathematical equations correctly, and I stated that these were orbital distances, and that is not correct. These are wavelengths that can double as a circumference, and by doing that you can find its orbital distance by finding the radius. Okay? Just wanted to clear that up and make a video about what I was really trying to mathematically show that I messed up on in my last video. Okay? Alright. Thank you for watching, and have a nice day.